Assalamualaikum warahmatullahi wabarakatuh, and good morning to all students. So we meet again in DRM1413 manufacturing technology. So today you are still in same topic, but then a new subtopic, which is turning and lathe. So now let's look at what are the content for today's topic. First of all, we are going to look at on the machining. We are going to look at the machine parts, its classification, and machining operation. Okay, and secondly, is turning. So we are going to look at the introduction for turning, cutting condition, and variety operations for turning. And last but not least is for lathe, engine lathe, which is actually the machine used to operate turning process. So in lathe machine, we are going to look at how the machine looks like and how to hold the workpiece and how to set up the workpiece before we start cutting the materials, cutting or remove the materials from our workpiece. So some of us were asking basically were asking the difference between machining and casting, because some of them were arguing because both of these processes actually might produce same types of product. Yeah, even though the target is actually producing types same type of product. However, there is certain difference between these types of processes, which includes, for example, machining might produce a final product with better accuracy, high accuracy, but of course it is a very, much more expensive process as compared to casting. And for casting, the process is much more simpler, very cheap, can produce many types of shapes, but it is not accurate and it's not precise. And normally, products which undergo casting might also proceed with finishing process, which require machining at the end of the process. So for machining, machining parts can be divided into two, which is rotational and non-rotational. For rotational, actually, the terms being calling rotational because the workpiece itself rotates instead of cutting tools. Cutting tools stay at one place, and meanwhile the workpiece will rotate. For example, turning process. So for non-rotational, the workpiece will stay, and the cutting tools will move. So cutting tools will rotate or moves in linear motion, and workpiece may only move like front, back, up and down. Okay, for example, like milling and sewing. So these are the parts that had gone through a rotational process, and this one non-rotational. So you can see the difference, because normally rotational, the parts is actually in cylindrical shape as compared to non-rotational. This one normally it is in rectangular or rectangular or non-circular shape. And for the machining operation, can be divided into two. Number one, generating, and number two is forming. So for generating, material removal is achieved by speed motion, and part shape is determined by the feed motion. For example, straight turning, taper turning, contour turning, peripheral milling, and profile milling. Meanwhile, for forming, the shape is created by geometry of the cutting tool itself. Cutting tool has the reverse of the desired shape, and cutting conditions, primary speed motion combined with a feeding motion. These are the example of generating machining operation, like being listed in previous slide just now. So this is what it looks like for straight turning. This is the cutting tool, and this one is workpiece. This one for taper, you can see there's a slight angle for a cutting tool being placed in order to produce a taper for our workpiece. And then this one contour, you can see that cutting tools following the contour shape of the workpiece. And then D, plane milling. Plane milling, this one is workpiece and this one is our cutting tool. And profile, this one cutting tool and this is our workpiece. And for forming machining operation, this one is form turning and this one is drilling, this one is broaching. Okay. Other than two types of machining operations just now, there are also some product which require combination of generating and forming forming operation. For example, thread cutting on lathe like this one, and slot milling. Okay, milling, and this one this is our workpiece. So now let's look at this machine. Okay, so now let's look at on turning operation itself. Okay, so turning operation it use single point tool. This is the single point tool, and this is the overall workpiece, which is cylindrical shape. It removes materials from workpiece by rotating the workpiece. So this workpiece actually being rotating. Turning is carried out on machine called lathe. So this process actually being conducted using machine which is called lathe machine. Okay, so that machines provide the parameters for us to cut the machine. For example, like depth of cut, speed, and so on and so forth. So this is what it looks like for lathe machine or engine lathe. You can see that it is being divided into several sections, which is, for example, headstock. So this is the headstock. It contains drive unit to rotate spindle, which rotates the work. Work represent the workpiece. And then you can see tailstock at the end of the machine, at the side of the machine. A center is mounted here to support the other end of the workpiece, so it won't move. Okay. Other than that, you can see tool post. This one is where the cutting tool being mounted. There are two types of engine lathe or two types of lathe machine, which is horizontal machine. This one actually being used for the workpiece that have its length, which is much higher than its diameter size. Whereas the other types of engine lathe is vertical turning machine, whereby this one is suitable for heavy machine with size of its diameter much more higher than its length. And if you notice this one, this is how we hold the specimen, our workpiece in general, which is around this one, this side. Okay. So it used two centers in headstock and tailstock. Headstock and tailstock just now. Okay, so this is headstock and this one tailstock. At headstock, a device called dog is used. So this is dog actually. This is dog. Okay. Tailstock has cone shape point. Okay. And tailstock center can be live or dead center. Live center means the bearing in tailstock that rotates has no tailstock rotates, so no friction. Dead center means tailstock does not rotate, which is fixed, but the workpiece rotates about it. So no friction between workpiece and tailstock. That's why dead center is used for to reduce the rotational speed. Meanwhile, for live center can be used at high speeds. And this is how we hold the specimen. I mean, in that part, we may found terms like, for example, chuck as the holding method. So chuck available in 3 or 4 jaws. This is chuck. Yeah, it's chuck. Jaws are designed to grasp or hold the inside diameter of tubular part and can be used with or without tailstock center. And we can also hold the workpiece using collet. This is the collet. It consists of tubular bushing. The inside diameter of collet is used to hold cylindrical workpiece. And number three is face plate. This one is face plate, yeah, fastened to lathe spindle and used to grasp parts with irregular shape. Number four, facing. Tool is fed radially. Okay, radially. If you notice from this one, workpiece is rotating, creating flat surface on the end. And number five is taper turning. So this is taper, this is cutting tool, and this one is workpiece. A tool is fed at an angle, creating a tapered cylindrical or conical shape. And then contour turning. Tool follows a contour that is not straight, creating contoured form in the turn part. So this is the contour shape. Form turning. Tool has a desired shape and fed radially into the workpiece. Chamfering. The cutting edge of the tool is used to cut an angle on the corner of the cylindrical. This one is chamfer. A cut-off tool is fed radially at certain location to cut off the end of the workpiece, like this one. Okay, that is cut off. And last but not least is thread. So a pointed tool is fed linearly across the outside surface of the rotating workpiece. The feed direction is parallel to the axis of rotation at large effective rate. As a result, threads are created like this one. Other than that, in turning, we need to know the cutting conditions which we might want to control, or the parameters that we want to control during turning operations. For example, turning speed. So this is the formula for turning speed, and final diameter of our product, and feed rate. This is the feed rate formula. Machining time or cutting time. This is the formula. If you notice this one, cutting times depending also on the feed rate, FR over here. So if you include, if you merge, substitute feed rate into machine time, you should be able to get this formula as well. And then volumetric rate, a volumetric rate of material removal. This is the formula. V is the speed, F is the feed, and D is depth of cut. So now let's look at the example for this topic. So let's read the question together. A cylindrical work part, 200 mm in diameter and 700 mm long, is to be turned in an engine lathe. Cutting speed equals to 2.3 meter per second. Feed equals to 0.32 mm revolution. And depth of cut equals to 1.8 mm. So find the cutting time and metal removal rate. So actually we just refer all the formula that been given to you just now. For example, for cutting time, this one, Tm equals to L over Fr. So Fr is calculated using this formula. Well, actually these formulas has been presented in the previous slide just now. So just substitute all the information in the formula, then you should be able to get the value of cutting time, which is equals to 9.96 meter. And meanwhile, for this one, if you substitute the value of this one, feed rate into cutting time, so you should be able to get this formula. And then if you substitute all the information using that formula, you should be able to get the same answer for this one. If you calculate differently, one by one separately. And for volumetric material removal, so using this formula, substitute all the information like the cutting speed, feed rate, and also a depth of cut. You should be able to get value which is 1320 mm cube per second. So second example, let's read it together. A tapered surface is to be turned on an automatic lathe. The workpiece is 750 mm long with minimum and maximum diameters of 100 mm and 200 mm at opposite ends. The automatic controls on the lathe permit the surface speed to be maintained at a constant value of 200 meter per minute by adjusting the rotational speed as a function of workpiece diameter. Feed equals to 0.25 mm per revolution and depth of cut equals to 3 mm. The rough geometry of the workpiece has already been formed and this operation will be the final cut. Determine A, the rotational speeds at the beginning and end of the cut. B, metal removal rate. And C, suppose that the automatic lathe with surface speed control is not available and conventional lathe must be used. Determine the rotational speed that would be required to complete the job. Machining time equals to 7.08 minutes. So for example number C, time is given to you. So you just rearrange back the formula. Finally, you should be able to get the rotational speed. So now let's solve this equation together. So we know that this is the formula for at this speed. So just substitute all the information, but this one is for beginning of the cut. We know that the beginning of the cut, D1 equals to 100 mm. Meanwhile, at the end of the cut, diameter change to 200 and cut. And cut 200 mm. So substitute all the information there. So you should be able to get the speed, which is equals to, for beginning of cut, 636 0.6 revolution per minute, and for at the end of cut, 318.3 revolution per minute. So secondly, a question asks you to find metal removal rate using the same formula. This one for the speed, this one is for feet, and this one depth of cut. So you'll be able to get the value of 150,000 mm cube per minute. And last but not least is the question asks you to find the speed that will be required to complete the job if the machining time equals to 7.08. So you just use the same formula and rearrange it back. So you should be able to get n equals to 4 to 3.5 revolution per minute. So that will be all for today's lecture. I hope you do understand what is being delivered to you. But still, if you do have any questions related to the topic, you can ask me anytime through WhatsApp group or Microsoft Team. With that, thank you very much. We shall see each other again in the next class. Okay, have fun and bye-bye.